Let's talk about that little blue dot on your phone's map. You probably use it every day, but what you might not know is that one of the greatest minds in history, Albert Einstein, is basically your co-pilot. Yeah, there's some seriously mind-bending physics hiding in your GPS.
I mean, really think about it for a second. There are satellites orbiting 20,000 kilometers above your head, and they can tell you where you're standing, usually down to the size of a living room. How on earth does that work? Well, the simple answer you might have heard, it's not the whole story. Not even close. Okay, so to get to the really wild part, we've got to start with the basics. The simple promise of how GPS is supposed to work in a perfect world.
So on the surface, it seems totally straightforward, right? A satellite way up there basically yells, "Hey, it's exactly this time and I'm right here." Your phone is like an amazing listener, picking up these signals from at least 4 different satellites. Since we know those signals travel at the speed of light, a constant, your phone can figure out how far away it is from each one. You get 4 distances, and boom, through some clever geometry called trilateration, it pinpoints the single spot on Earth where you have to be. Sounds easy enough.
Yeah, not quite. This beautiful, simple model has a huge problem. And it's not some small engineering glitch. It's a flaw that's literally baked into the fabric of space and time itself. See, the problem is that the most basic assumption in that whole process is just wrong. The idea that time is this constant, universal clock ticking away at the exact same speed for everyone everywhere, it's completely, totally false.
And here's the thing. The engineers who built the GPS system, they knew this from the get-go. They knew that the atomic clocks on these satellites, clocks that are so precise they won't lose a second in millions of years, would still be wrong. They're almost perfect, but they still need to be adjusted. And that right there is the key to this whole puzzle.
So why do they need adjusting? Well, here it is. Time itself literally moves at a different speed for a satellite zooming through orbit than it does for you standing down here on Earth. Your watch and the satellite's clock are fundamentally out of sync.
So, how in the world do you fix a problem with time itself? Well, you turn to the one person who actually figured all this out more than 100 years ago, Albert Einstein, and his incredible theory of relativity. Okay, so Einstein's work creates this kind of cosmic tug-of-war that's constantly messing with the satellite's clocks. On one side, you have his special theory of relativity. All it says is, the faster you move, the slower time passes for you. On the other side, pulling in the opposite direction, is his general theory of relativity. That one says the stronger the gravity you're feeling, the slower time passes. And the GPS satellites are caught right in the middle of this epic battle. All right, let's look at the first force in this tug-of-war, speed. These GPS satellites are absolutely screaming through space at 14,000 kilometers an hour. That incredible speed actually causes their clocks to tick a little bit slower than ours down on the ground. They lose about 7 microseconds, that's 7 millionths of a second, every single day. Okay, sounds like nothing, right? Just hang on to that number. But now for the other side of the tug-of-war, gravity. The satellites are way up high, so Earth's gravitational pull is a lot weaker for them. According to general relativity, this weaker gravity makes their clocks tick faster than ours. And this effect is way more powerful. It causes the clocks to gain about 45 microseconds every day. So you have this cosmic battle, right? Speed is slowing time down a tiny bit, but the lack of gravity is speeding it up a whole lot more. At that specific altitude where the GPS satellites orbit, it's not even a close fight. The effect from weaker gravity completely overpowers the effect from speed. So gravity wins this round, big time. So what's the big deal? A few millionths of a second? Who cares, right? Well, it turns out that in a system that relies on timing to figure out distance, a few millionths of a second isn't just a big deal, it's everything. Let's just do the quick math. You take the 45 microseconds the clock gains from weaker gravity, then you subtract the 7 microseconds it loses from its speed, and what do you get? You get a net gain. The satellite clocks run faster than clocks on Earth by exactly 38 microseconds every single day. And that, right there, is the universe-sized flaw. A 38 microsecond error sounds tiny, but remember, we're calculating distance using the speed of light. That tiny time gap translates into a positioning error that grows by more than 11 kilometers every single day. If we ignored relativity, your GPS would be completely useless in less than a day. So how did they fix this fundamental problem of the universe? Honestly, with one of the most brilliant engineering hacks ever. They used Einstein's own theories against the problem. Before they even launch a satellite, they intentionally engineer its atomic clock to run slow on the ground by exactly 38 microseconds per day. That way, once it gets into orbit, the effects of relativity speed it up to the perfect rate, keeping it in perfect sync with us here on Earth. It's genius. Now, to be fair, relativity is the big boss battle, but it's not the only challenge. The engineers also had to solve a few other tricky problems caused by our own planet. The system also has to constantly correct for other stuff. For example, the signals get a little bit bent and slowed down as they pass through our atmosphere. Sometimes they even bounce off tall buildings, which can throw off the timing. The system is always adjusting for these things. But look at the numbers. A few meters here, a meter there. Nothing, and I mean nothing, comes close to that massive system-breaking 11-kilometer daily error caused by relativity. So let's bring it all home. What does this really mean for that amazing little device sitting in your pocket right now? Well, it means the next time you use your phone to find the nearest coffee shop, just remember what's happening. You're not just using a map. You're a participant in a massive, global-scale physics experiment that is proving Einstein's theories of relativity are correct, every second of every day. The source material really says it perfectly. GPS is a practical engineering application of the scientific theory of relativity in a real-world environment. This isn't just some abstract idea in a dusty textbook. It is fundamental, invisible science that makes a huge part of our modern world actually work. And that just leaves you with a pretty cool thought, doesn't it? If some of the deepest principles of the universe are secretly at work inside your phone's map app, what other incredible invisible physics is hiding in plain sight, shaping the world all around us?